Hello, let's see how we can find the number of leaf nodes in a binary tree. So the property of a leaf node, as we already know, is that there is no left or right child on those nodes. So for example, in this test case, we have 4 leaf nodes, 3, 4, 5, and 6. These 3 are not leaf nodes. So how can we solve this? So the recursive solution that comes to mind is pretty simple. Here is the pseudocode, leaf nodes. We start from the root node, and then since it's going to be a recursive solution, we need to find some terminating conditions. First condition is if this node is equal to none, we return 0. Then our main condition where we check if node dot left is equal to none and node dot right equal to none, then we know we have found a leaf node, and we return 1, that we found one leaf node. So these are the two terminating conditions, and then in here we are going to return the current nodes. We are recursively going to call leaf nodes function with the current nodes left, node dot left, plus leaf nodes of node dot right. So that's about it. Now let's run this test case against our code. So what happens is, first time leaf node function is called with value 0. Then leaf node checks, is it 0? No. Are there children? None? No. So the control comes here, and the leaf node is recursively called with left value of 0, which is 1. So we call leaf node with value 1. Then control comes here. If these conditions are not true, so again leaf node 1 calls leaf node with its left, which is 3. So it's going to call leaf node 3. Then what happens is, in the next iteration when we are here, we check this condition is not true. This condition is true. 3 has no children, so 3 returns 1, a value, and number 1, count 1, to the function that called it. So now this function for 1 is done. It returned it a value 1, which was with 3. And then the right side, this function is going to be executed. So 1 will call leaf node function with the value 4. When we call with 4, this condition is not true, but this is true. So this will again return 1. So now when the leaf node function called with node 1 has 1 plus 1. This one was returned by 3, this one is returned by 4. So overall, this function when called with 1 is going to return 2. So 2 is returned to 0 from 1. So now we are here, we are in the leaf node function when it was with node 0. Its left side is done and it returned us value 2. All this thing was at its left side. Then we call the right side of 0, which is leaf node of 2. 2 is again going to check these conditions. These are not true. So its left side is called with 5. With 5, we are here. This is not true, but this is true. So 5 returns 1. Again, so this part is done for 2. Now this part for 2 is going to be executed, which is leaf node of value 6. It comes here. This is not true. This is true. So 6 will also return a value of 1. So now 2 will have 1 plus 1 returned from 5 and 6 respectively. So 2 will return a total count of 2 to 0. So we noticed earlier that the left side of 0, which was this side, returned as 2, and the right side also now returned as 2. So overall 2 plus 2, 4 is going to be returned by this function, which is the right number of leaf nodes as we see here. Thank you.